Welcome back to another episode of the RS001 Audi Quattro Group S car build. So today we're going to do some math, and there's going to be a few arms in the actual B-roll, but that's all right. We're not professionals at this gig, so we try our hardest anyway. But we've got some stuff for the roll bars to complete the front suspension, and we're going to start putting some parts on in readiness for the plumbing and fuel system installation. And also brakes are on the way, so they should be here next week as well, so we'll cover those later. We might even have a little sneaky tour of the Alcon factory, so they've got to just lock down a few bits and pieces and just make it Australian friendly and safe for us to come down there and just, you know, raid their store cupboard. So that's going to be really exciting. So yeah, please, if you're not already liked and subscribed, make sure you do, and hope you enjoy the video. Okay, this is a fuel cell that we're going to use in the vehicle. This is built by ATL, and it's actually been FIA approved as well. So, cut. Take two. Right, this is the fuel cell that we're going to use in the vehicle. This is all made by ATL. It's FIA approved, and that basically allows, it comes with a certificate. So it means it's all safe, user-friendly for motorsport use. So we need that for future events. It's 60 litres, and this has got a nuke performance insert for the actual fuel cell. And built into that, we've got 4 fuel pumps, two lift pumps, 2 high pressure pumps, and one of them is also speed controlled as well. And so it's a really neat installation, this. And it saves having an external swirl pot and external pumps and fittings and plumbing, and it actually becomes quite a lot more economical to you know, manufacture a tank this way. And so all you have now is electrical connections, and then you have an outlet to the fuel system in the back and a return line, filler, fuel level. So being a 60 litre, fuel's weight, it's heavy, so we don't, you know, you don't always have to run with a full tank of fuel just to make sure that everything's okay. So because it's got a built-in swirl pot assembly for when we go around corners and stuff like that, we can actually still make sure that we've got fuel that's going to be available for the high pressure pumps to keep the engine alive and working correctly. And that will allow us to run with like a lower fuel level. So we could perhaps run with, like, say 5 or 10 litres at some stage. And then because the internal swirl pot or collector will always be full of fuel, we'll have the reliability out of the system, really. So it's a really nice installation, and it works out quite well. It fits in the chassis perfect, and yeah, it works quite well. So yeah, I'll show you the rest of the system now if you want. I'm going to do some math. Right, so basically this is our target. Our target is 1,000 horsepower worth of fuel. Okay, now a race car, to me, a race car needs to run on race fuel. And where you get the power from any engine is by the fuel. And so we use a VP Racing fuel, which is a Q16, and it's 120 plus octane. So they can't measure it once it's above 120. So it's it's oxygenated as well. So there's, I think, 5 to 6% or something extra oxygen as well. And it's quite a good fuel, and it's very dense as well. So we don't need to have, when you run E85 fuel or methanol, E85 fuel, you need 30% more fuel. Methanol, you need 2 times the fuel of normal petrol. So when you run the Q16 fuel, it's like running normal unleaded. You don't need extra capacity of the fuel in the actual tank, so you don't need lots of it. So that sort of helps. And so our target horsepower that we want to achieve is 1,000 horsepower out of this vehicle. And so that needs to be at 0.8 lambda, which is your air fuel ratio. And so if you do the math, you need 6,000 cc's per minute of fuel flow. And that's what you need to come through the injectors. Okay, so that's basically what I've got there. So you can see here we've got 1100 cc injectors in the vehicle, which doesn't quite equate to this 6,000, but with the fuel system, you have a fuel pressure regulator, which is just here, and that has a manifold pressure reference. And so that connected to the intake manifold, when the turbo pressure comes in, it then increases the fuel pressure, and then that increases the fuel volume through the injectors. So when these injectors are at 1100 cc at normal 3-bar fuel pressure, that's fine. And then when you've got say 2.5 bar of boost, that fuel flow will probably be up to like 1400, maybe 1500 cc out of the injectors. So that's how we get away with using a 1100 cc injector with this 6,000 cc like fuel flow that is required to make 1,000 horsepower at that fuel mixture. Okay, now to feed the injectors, you need pumps. So the pumps that are in here, we've got 2 lift pumps that are in the fuel tank. They basically float around the bottom of the fuel tank, and then they feed the collector that's inside it. And inside that collector, we've got a high pressure pump, just a standard on-off type high pressure pump, and then we've got a speed controlled high pressure pump. And we've got a controller for the high pressure pump. And that will allow the high pressure pump, when it's at low running, low RPM, etc., it can then slow down the speed of the pump, and so it won't deliver as much volume, because the engine doesn't consume the fuel when it's at idle. It's probably making, I don't know, 5-10 horsepower. So we don't need to have this, you know, fuel flow in the vehicle. So that will allow us to slow the actual pump speed down. So made by ProTech, lovely little bit of kit. And yeah, so, and then what will happen is the PDM, the power distribution module, will operate the pumps. So they'll be sending the power to it. And then the ECU will be triggering the PDM to tell it when to turn the pumps on and off. And what we could also do with the PDM and the ECU is these can be staged. So like when you're at tick over and idling or first starting up, you probably only need 1 pump and 1 lift pump to operate. And then when you want to get a bit jiggy with the old gas pedal, then you can turn the others on. Okay, so that's the joy of having the PDM control it and the ECU control it. Okay, now after that, this will be the feed line. This will be the fuel filter, which is this unit here, little fuel lab jobby. You've got to have elements inside it, and we tend to use the stainless steel elements because they tend to be a lot, it's quite a harsh environment, race fuel. You really don't want to be putting a paper element in a fuel filter when you've got a race car, because, you know, like the additives in the fuel are pretty aggressive, and it can sometimes cause damage to parts, and they can melt and cause you problems. So 10 microns is basically the size of the element, and so the smaller the number, the finer the filtration. So these filters down here, these are probably about a 60 micron filter. They just stop the big stuff crawling into the pumps, because if you get any crap in your pump, it's over. It's going to damage the pump and it'll stop it working. And then the 10 micron stops all the fine stuff. So if you get any dirt, debris or whatever, it just stops them entering the injectors. Okay. Then up into the rail, we've got the 5 injectors, the as new 1100s. And these are all like a special Bosch Motorsport core, and they're metal to metal seats, so that they'll take any fuel quality or additives or anything like that. They won't damage the injectors when you operate them with race fuel. You also need to make sure the rail's big, because you can imagine if this through hole of fuel pressure and fuel volume through it is very tiny, when each injector's taking its little bit, you end up with like a waveform of fuel flow that comes through the rail. And then if an injector is on an opening when it's got less pressure, potentially you get like a lean operation of fuel that goes to that cylinder. So really you've got to have capacity in the fuel rail so that each injector has got plenty of fuel and plenty of volume and the same pressure everywhere. And we also monitor the pressure just before the rail with a fuel pressure sensor, and that'll be linked to the engine ECU, and then that will then be able to detect if the pressure's decreasing or increasing, and then it'll adjust the injector opening according to that. Fuel pressure regulator will be a TurboSmart unit, and then that's all adjustable, so we can set the base pressure, probably about 4 bar we're gonna run. And then you need that fairly close to the fuel rail, and that will then dampen out any oscillations that you get from the injector operation and the fuel rail and stuff like that. Then that's it. That returns back into the swirl pot or to the collector. And so that will then constantly keep this topped up. And so when you back off and decelerate, that'll be topping up. Your lift pumps will be feeding that up with fuel. And then, yeah, that's it really. So, did you get all that? Right, well, this is a lifesaver, this machine, and we use this machine quite often at EPS. And what we can do here is we can flow the injectors at various pressures, and we could also change the battery voltage to simulate what it's going to be like in the car. So if we don't have the information from the flow of the injectors, we could then put it in the machine, get some characterization and stuff like that for the actual injector, because each injector doesn't flow, it's not linear, it's output. So when you use a Motec system, the ECU has got a linear flow calculation of the actual injector in it. And so what's involved is you'd send an injector to Australia, they put it in this massive machine, and it's nearly a 2-day test that it gets run on, and they operate the injector at different battery voltages, different fuel pressures, and also different injector openings, and then everything's like weighed and documented. And then once you've got all that documentation, you could actually make different flow or different tables of how much volume is going to come out of the injector at different pressures and voltages, and different openings as well. And then once you've got that info, you could then, when the engine's mapped on volumetric efficiency, it then just needs to know, okay, if the fuel pressure is this, the battery voltage is this, we need to open the injector at different openings. And you could also see, as an example on this machine here, we've done a little flow test at various pressures to show the different amount of volumes of fuel that you've got available from the different pressures. So that's how you can get away with using like a 1100cc injector for making like 1,000 horsepower, which is what we're going to use for, because really you should have about 1,200 or 1,300 cc's of fuel available for it. And by adding the extra pressure on because of the fuel pressure regulator, this then increases the volume, and then that will give us enough fuel to do the job.
And then, did you mention about the not having the 5th injector? So you might have done. I might have just decided to
Very well spotted. As we have a Audi 5-cylinder, We are missing an injector here. That's because it's up in the office upstairs and I can't be bothered to get it. So yeah, very well noted. It'll save on a few comments, I think, being a 5-cylinder and we've only got 4 injectors. So yeah, well, it was a test. Right, the way this machine works is this is pretty much the whole car's fuel system. So behind here there's a tank of fluid, and here we've got a fuel pressure or fuel pump inside the machine here, and here we could adjust the actual fuel rail pressure. So as a little test, we'll just do like a full open test. And so the pump's running, we're at 5 bar of fuel pressure, and then we can operate the injector through different modes. And this is basically flat out, so 100% open. And so with this, you can just make sure that all the volumes of each injector are exactly the same. Besides missing of 1 cylinder, that's perfect, all the same. So this is the M1 ECU software that we're going to be using in the vehicle, and this is the actual main fuel table. So this is what they call three-dimensional mapped. So here we have the engine's turbocharger pressure, then here we have the engine speed, and then up and down is basically the volumetric efficiency of the engine. So once we map the engine for its correct volumetric efficiency, a part of that calculation really relies on the injector, or knowing what the injector does. And the joy of like the tests that we've done with the ASNU injectors back in Melbourne, Australia, they've correlated all that data, and then we kind of know if the battery voltage is this in the background and the fuel pressure is this, it will then change the injector opening to allow it to have the correct lambda and obviously maintain the correct mixture to do its job. And so what it actually uses, it uses this table that we've got here. So if we go across to here, and which is this one, injectors, we'll make this slightly bigger. And then these are the tables that we have available. So this is fuel pressure versus battery voltage, and then up the top here is all the different tables. So you can see how many tables are actually being occupied for the amount of different openings and different fuel pressures. And it goes to show here, see at 6 volts of battery voltage, you've got a number of 4.9, and then obviously at 15 volts, because voltage is like, it's like compression, isn't it? The higher the voltage is, the faster it will react. And so you don't have to operate the injector for as long. And so you can see it's like got a number of 1.6 in it. So this is just one of the small parts of making your car run correctly and reliably. And yeah, that's it really. So yeah. thanks for watching. Hope you didn't glaze over too much. I hope I didn't say too much as well. Next video, we've got the oil system I need to get on with, and also hopefully we'll have the drive shafts back from the coating process that's been done to them. And we should also have, yeah, lots more parts to bolt on. So hope you enjoyed the video, and please like and subscribe, and we'll see you soon. Oh yeah, also thanks to Competition Supplies for the paint repair kit. We've actually fixed the scratch in the back bumper bar and it looks mint. No one will even know.